Hello everybody, this is Haruna.
Hi, this is Rashmi.
And welcome to our third session, Introduction to Scratch. I'm going to switch over to our slides.
Mm-hmm.
I can get there. Where's my toolbar?
Just click on it. Yeah. It's playing hide and seek.
Sorry, my toolbar was disappearing on me.
It's playing hide and seek.
And there we go. So again, this is session 3, Introduction to Scratch. And if you're with us live, please also open today's Meet, Coding Sampler 3. I see that a few of you are in there already. And again, if you have any questions, feel free to type it in there.
Mm-hmm.
So we're going to jump right in. What is Scratch? Scratch is a graphical programming platform. It's a block-based coding platform based on C, which is another popular programming language that it's sort of gone obsolete, but it was very popular back in like
when we were
90s.
studying.
When we were in college, that's basically what we learned as our first computer science course.
Right.
It was developed by MIT specifically for the education community, and there are over 10 million users worldwide. A lot of them are student age population. And it's designed for making animations in games, but it is a very powerful language that actually can do a lot more than just making animations in games. But the interface is such that it's very, it's kind of made specifically for animations in games, and it's very easy to make really nice looking video effects in it.
Mm-hmm.
And it's not so much for just pure computation like the C languages, because it is video based, but it can do a lot more than animations in games if you want to go there. It is free and it is online. There is an online platform where you just need internet connection. It runs right in your browser, or there's a version that you can download and install locally on your computer if you don't have reliable internet. So it's very flexible in that sense. It's good for Macs, PCs, and Chromebook. Again, Chromebooks, if you have internet connection, it works right in your browser. It's very easy to integrate with other subjects, so you can create projects in Scratch that relates to science or math or art or ELA or you name it. There are different projects you can do in Scratch. There are some connectivity to some hardware. So, for example, you can program the Lego We Do kits using Scratch. It also works very well with Makey Makeys, which we'll go into in our hardware sampler, which is session 12, I believe.
A face-to-face session.
Yes, face-to-face session.
Absolutely.
And it is recommended for grades 3 and up meaning all the way through high school, and even in college people can use this. It's not text-based, it is graphic-based, but you can do so much in there that even college students can use it. And I've seen people younger than grade 3 use it as well, but there are other options for those at younger age that we'll get into in the coming weeks as well. So the couple of different words that I want to go through before we jump into Scratch. One, the most important thing in Scratch is Sprite. It's a strange name, but it refers to any kind of character or objects or anything that does things in your project is a sprite. So if you imagine that video game, like the main character might be a sprite, or any sort of items or like objects that you interact with during your program is going to be a sprite. Each sprite may have multiple costumes, which are just the physical appearance. So can't think of a good example. Well, we'll get into that once we get into the programming. And then there's the stage, which is basically the background. So if you have a video game, the screen background is the stage. And you can have multiple backdrops, so multiple different scenes in your project as well. And then there's the script. Whoops, this is running off the page. Script, which is basically a code that is made up of a series of different blocks. And the script is what governs the behavior of a sprite and the stage. And each sprite will have its own script.
Right. And in order to also, when you think about sprites and as objects, it sort of lays down the basis for your understanding of, as you go into text-based programming, it gives you an understanding of how you're moving object on the screen. So that's a really great way of looking at block-based programming.
So we'll be using a lot of these words, sprite, stage, and script, as we go through the day, so just remember what they are. And then we're going to jump right into Scratch. So Scratch is at scratch.mit.edu. This is where you will land. And I've already logged in as myself. If you don't already have an account, don't worry about it. You'll just see like a sign in or create account here. You can create an account, and it's going to ask you to verify your account using your email address, and that's so that you can create studios and things like that. But you don't have to do it now. You can just watch for now and do it at a later time. If you already have an account, you can go ahead and log in. Once you log in, there are a bunch of different tabs. And I'm not going to go through all of them, but the Create tab is where we will actually do the programming, and I'm not going to click on it right now. There is an Explore tab, which shows you different interesting projects that you can take a look at. Discuss, which is a discussion forum, and it's actually a pretty active discussion forum, so you see that there's a lot of posts even today. And people ask questions like, oh, I want to do this thing in Scratch, but I don't know how to do it. And there will be some experts that will jump on and be able to help you at some point. The About page talks just about the background for Scratch. And then the Help menu is actually very useful. So I want to show you that. So there are Getting Started guides and some one-pager cards for things interesting things you can do. And there are also a lot of video tutorials. Also, there is a Scratch Ed
community,
which is an online community specifically for educators who are using Scratch. And if you go in there, there are curriculums and activity ideas and a whole slew of other things. And there is another discussion board for educators. This discussion board is not as active as the other one. So if you do want to use a discussion board to ask questions about Scratch, I actually suggest you use the other one in the main page. Back in the Help menu, there's also Scratch Wiki, which pretty much tells you anything you want to know about Scratch. So once we get into the programming, you'll see that there are a lot of different blocks and different commands. The wiki will have an entry for every single one of those things, which will vary in a lot of great details. It'll tell you how to use each block. And then this is also where you download the offline versions. There's Scratch 2 offline, which is the newest one, and then Scratch 1.4 if you want the old version for any reason. And these will open up the installers, and you can download the installers and install it on your Mac or PC. And then you don't need internet to do Scratch. So I think I am good. And once you start programming in there, your stuff will appear under My Stuff tab. I'm going to go ahead and go in there. And you probably won't see this many things because this is all the stuff that I've created. One little thing about Scratch is once you start creating the program, it saves automatically. So even if you open a program for like 2 minutes or 2 seconds and close it off, you still have a version saved. So I usually end up with all these untitled ones that I started. I just happen to open the window to take a screenshot or something, and then I close it, but it saves the draft already. So if you get a lot of these untitled ones, you can just go ahead and delete them if you don't need it anymore. But all the other projects will be saved in here, and you'll see that there are shared ones and unshared ones. Anything with these extra icons are shared, which means they're public. Any of them that don't have it is still private. And actually, Scratch will put them in different folders for you. So I have shared projects and unshared projects, and we'll talk about that soon. So let's show you one example project. Let's start with this one. So this is a sample project I did for I can't remember what I did it for, but it's a very simple program. So now I started it. If I hit the space bar, the cat will jump. And the objective in this game is to squash these balls that are coming rolling down. And in this case, the cat is a sprite. The ball is also a sprite if you look at the bottom of the page. And I also have additional sprites, which are the background images. Because the palm tree and the hills are moving, they're actually sprites. They're not just the background. The stage itself, the part of the background that doesn't move at all is just this green grass. And then we have the mountains that move and the palm tree that moves and then the ball that comes rolling down. And as I click on each of these sprites, you see that every one of them has its own script. And again, if I jump, and I can squash the beach ball. And one thing I mentioned about the costumes, you see that the cat is moving, but it looks like it's walking because it's switching between two different costumes. And if I go into costume menu, you can see that it's flipping back and forth between two different poses. And that's why it looks like it's walking. And the same thing with the beach ball. There is a round beach ball costume, and then as soon as I squash it, it becomes a flattened beach ball. So there's two different costumes there as well. So those are the different things you'll see once you get into Scratch. And let's see. I'm going to show you, actually no, let me not show you anything else. I'm going to start with a blank slate. So I'm going to go ahead and click on Create tab and show you how to get started in a program. So when you start a new program, this is what you see. So this white part here is the stage, and right now it is a blank stage. You start with a default sprite, which is this cat. It's actually called Scratchy the cat. But you can change it. You can add more sprites. You can edit this sprite. You can change it to something else. And then in the middle of the page, you see all the code, all the blocks, which are color-coded in different tabs. And we'll go through some of these in a minute. And then you also have the costume tab. For this, this cat has two costumes already built in. Some sprites will not. And then there's a sound tab, which we may not get into today. The file name is up here, Untitled 22. You can change that, and again, it auto-saves. There are also some saving options here, edit options, so on. This share button on the top right is what you will click once you are done with your project and ready to make it public. And we'll go through that a little bit later when I'm done with this project. The globe icon on the top left corner is actually pretty interesting. Scratch comes in various different languages. I forgot how many, but it comes in a lot of different languages. So if you have, let's say I wanna do it in Spanish, so I'm gonna pick Español. And now all the icons switch to Spanish. So if you have students who may not be English speakers or English readers and want to try this in a different language, you can still do so. And even if you're in the middle of programming and you already have a script built, you can switch it to a different language and it will switch, everything will switch. Also, if you have, if you were working on a Scratch project with a student, but then a student's parent comes to look at it and the parent doesn't speak English, you can switch it to a different language and show the parent and explain to the parent what's going on too. So it's a really nice feature. So that's the globe right there. Okay, so a good thing to do when you're trying to program in Scratch, or actually trying to program in anything, is to have a plan before you start programming. And the reason being, if you have a plan and a goal and something that you want to get to, the problem solving that's required to achieve that becomes a lot more authentic than just playing around and putting codes together randomly and seeing what happens. So I'm going to show you what my plan is. My plan today is to make a very simple project. I'm going to have two different characters, the yellow person and the blue person in this picture, in this little sketch. It's going to start at either side of the screen. They will move to the middle of the screen, and I'm going to do a little animation of them like doing paper, rock, scissors, and then the winner will jump up and down. So it's a very simple project that I'm going to try to do right now. So back in Scratch. So one thing I need to do is add a sprite because I need two different characters. So I'm going to keep the cat for now, for one of the characters, and then I'm going to add a second one. So there are several different ways to add a new sprite. Everything is in the bottom corner here. First one is to do a choose sprite from a library. Scratch has a pretty extensive library of pre-existing sprites. You could also paint a new sprite. You can draw a new one. Or you can upload a sprite from file if you have a graphic file, if you have any photo or anything you want to use. Or you can use your computer's camera to take a new sprite. Right now, I am just going to pick one from the library. So let's see. I am going to pick, let's see, pick this dinosaur. Okay. So now I have two sprites. So I am going to first practice moving the sprite. And oh, I need to show you one thing. So the stage has coordinates, and go back to my presentation for a second. So in Scratch, the center of the stage is 0, 0, and then you have X going horizontally, Y going vertically. X is 480 pixels wide, but because 0, 0 is in the middle, we go from minus 240 to positive 240 horizontally. And then on the y-axis, we have 0 in the middle. It goes from negative 180 to positive 180, and 360 pixels high altogether. So you just need to remember that a little bit as we go.
So we have two questions,
Yep.
Haruna. First is there a space where we can research specific project ideas related to content?
I'm a little bit confused as to what you mean by research ideas. You can definitely search in Scratch. There is a search bar in Scratch that you can search different projects.
Okay.
The one challenge with that is there are so many projects out there, and it doesn't necessarily mean that people have tagged them in a useful manner. So
Right.
Unless the projects have been tagged in a very useful way, you may not find it. But that's one way to do it. Otherwise, I would
Right.
just Google it, and I typically find a lot of different resources.
Right. So I did ask the clarifying question, is it by content ideas? And we'll know. Just on that.
Is it?
Yes.
And what was the other question?
I need to get back on.
Oh,
Give
is
me
this
one
session
quick
geared
second.
towards elementary students? Is that the second question?
Yes.
Okay.
Yes.
So Scratch
Wherever you
is
introduce
used in grades 3 and up. So this definitely could be used by elementary students.
Or
but
where
it's,
you introduce.
or it could be also used by middle and high school students.
Yes.
So, and it really depends on how much you want to do with it.
Mhm.
Some of the advanced gaming things that we'll cover later on in the other session probably may not be appropriate in elementary school, but animating and making like the things we're doing today is definitely applicable in
Right.
elementary school.
And think of it wherever you are going to introduce Scratch to your students. So if it's in the middle schools, then this session will be helpful to you in the middle school or high school, wherever you are introducing Scratch.
Right. Yeah, so think of this as first session, or depending on where your students are,
Right.
you may even do more introductory things before you get here. But this would be something like more of a introductory lesson on Scratch. Okay, so back to my project. I need to figure out how to move my sprites. So I'm going to go into the motion tab for the scripts, and there are different ways to move things in Scratch. Actually, you'll find that many times in any kind of coding situation, there are multiple ways to do anything. So to create a program in Scratch, you just drag the block from the palette out to the right side of the screen, and you can click on it to try it out. So as I'm telling my cat to move 10 steps, it's moving 10 steps. And you notice that the dinosaur is not moving because I'm in my cat space. And again, each sprite has its own script. So if I'm only using the script on my cat is the only one that moves. Okay, so I can make it move this way. I can also make it move by a go-to command. Now, go-to command will make the cat just teleport to a different spot in the page. So let's say I'm going to change it to X 100. So I'm going to drag it back to the left side, click, and it will jump to the right side of the screen. The other thing we can do is glide to. So now if I say glide to, it will slowly move to the right side of the screen, which may be better if you want the program to take any substantial amount of time. One problem with using the go-to is, let's say I want the cat to go from left to right and back to the left side. and so it's going to go from positive 100. Well, it's going to go start where it is now, go to plus 100, and then go to minus 100. The problem with doing this is that everything happens so fast that you don't even see it going here and then back. So if I do the same thing using glide to, then you will actually see it moving to the right and then moving to the left. So that's 2 ways of moving things. And now I'm going back to my move command. The move command is also very useful if you combine it with, when you want to combine it with a repeat block. Repeat block will take any command that's inside the repeat block and repeat it specified number of times. So to get from minus 100 to plus 100, I need to move 10 steps 20 times, right? So now if I do that, it moves. And then I can, let's say, duplicate that. And I'm duplicating things by right-clicking on the blocks. And then there's an option to duplicate. So I can do something. Whoops, sorry, I did not drag it back. So I can also do that. So these are 3 different ways of doing essentially the same thing. So let me go back to this. So the first one, the go to 100 and then go to minus 100 happened so quickly that we couldn't see anything, but I could also insert a wait block. Wait block in between. So now you will see it when it's at the positive side. It'll stop there before going back. So the wait block is also very useful to slow things down. So that's 3 different ways to make the cat move forward and back. And different commands work well for different purposes. So it will be pretty much up to you to decide which one you would like to use for your particular project. You have a question?
No, just a suggestion that there is a graph background in Scratch.
Yes.
So maybe.
Yeah, I will show that in a minute.
Thank you, Amolo. We'll share that with the teachers.
One thing you will notice is on the bottom right corner of your stage, you will see the X and Y coordinates. So if you're pointing to a specific place on the screen, you will see that displayed on the X and Y. So you can use that as a guide to figure out where you want to move to. The other thing you will see is that as I move my cat, let's say I drop my cat towards the middle of the screen. All of these go-to icons, go to X and Y, or glide to, their X and Y values change to where I am right now. So if I know that I want to start in this corner, I can drag my cat to where I want to start, and then, let me clear my screen first, sorry. I can drag my cat to where I want to start, and then drag out one of my go-tos. So that would be my initial location. And then I'm going to drag my cat to where I want to end up, which is towards the middle of the screen, and then put another go-to icon there. Now, I pretty much have what I need in order to move. So I don't have to do any guesswork in terms of where I want, what coordinates I need to put in. I am actually going to change this to glide too. Sorry about that. Okay. So I have the cat, and it moves to the middle of the screen. So now I need my dinosaur to do the same thing, but from the right side. So first thing I'm going to do is actually to copy this code, which I know that it's already working, from here to the dinosaur. And the way to do it is to take this and just drag it right over into the dinosaur and let go when you're over the dinosaur sprite. And it doesn't look like anything is happening, but if you click on the dinosaur, the script is magically there. So this is going to take a few times to get used to because it doesn't tell you any kind of, there's no audible or visual sign that anything actually happened. But you can drop it onto your sprite and it will copy the code right over. So, but I do want the dinosaur to start on the right side. So instead of saying negative 189, I'm going to do positive 189. And this, I'm going to change that to a positive as well. Okay, so now the dinosaur is moving, but he's walking backwards. So what I need to do is something called a set rotation style. So the rotation style is how you want this sprite to behave when it's moving in different directions. So there is a left-right, which will make the sprite flip left and right depending on which way it's moving. And there is a don't rotate, which is what it's doing now. And there's all around, which I will show you in a minute with a different sprite. So, so I'm gonna stick that in the front. Wait a minute, why is that not working? Oh, because I did not point my dinosaur to the other direction. So there is a point in direction block that you can use to make it switch directions. So now it's facing the other way. Now if I didn't, if I say rotation style, don't rotate and flip the dinosaur to the left direction, then what you will see is it doesn't rotate. It stays facing the right side, although it's technically facing the left side. If I say all around, now it flips. So if I say all around, it basically, I'm just going to demonstrate with this turn. It just turns whichever direction you want to go. And if I have the rotation style set to left and right, as it turns, it will stay facing right until it kind of crosses over the vertical, and then it flips all of a sudden to the left side rather than doing the slow turning. So I'm going to keep it left-right. I will have it pointing to the left, which is negative 90, and then move. So now my challenge now is to make these two scripts for the cat and the dinosaur start at the same time. And what we want to use there is this green flag hat. So I'm going to put this green flag on top of each of the codes. And what this does is if I click the green flag on the top of the screen, both codes will start at the same time. And now both of the sprites are synced, and they both move at the same time, and they meet in the middle to play paper, rock, scissors. So to make them play paper, rock, scissors, I'm not going to do a fancy animation. All I'm going to do is make the cat say rock, paper, scissors for 2 seconds. So that was under the looks menu. There is a say icon. There are two different say commands. And this doesn't produce any sound. All it does is do a speech bubble. Same thing with the think command. Think command does a speech bubble, but it just looks a little bit different. And you can specify a time. So this one is saying it for 2 seconds. Or you can not specify a time, and it'll just keep the speech bubble there until you get rid of it, until you erase it in the program. Okay. So again, it's doing the paper, rock, scissors. And let's see. I'm going to have the cat be scissors. And the dinosaur will say, what beats scissors? Rock.
Rock.
And remember that the cat spent 2 seconds saying paper, rock, scissors. So I'm going to have to make the dinosaur wait 2 seconds before it says rock. They meet in the middle, paper, rock, scissors. And scissors and rock, although you couldn't really see the rock. And so my plan was to have the winner jump up and down and say, I won. So now the winner is the dinosaurs. I need the dinosaur to jump up and down. So to jump up and down, I will have him move. Let's see. So I'm going to show you a different way to make things move. There is a change X by and change Y by. So that will take whatever position it's in, and if I say change y by 20, it will just move it up 20, which seemed like a big enough jump, so I'm going to make it 50. I just duplicated that, and then I need to make him come back to the bottom. And let's also repeat this so that it looks like he's jumping up and down. Okay, let's try that out. Okay, so what happened now was I forgot to put the weight in here. So everything happened too quickly, and I could not see it actually jumping. So I am going to insert some weight in here. And let's see how that goes now. Okay, it's a little slow. I'm gonna make it a little faster, but that's basically the gist of my program. Very simple, but it went through a lot of the motion icons, the weights, and the repeats, which I definitely want you to figure out how to use. There we go. Okay, and so now that I have the basic program, I'm gonna show you the stage. And if you want to edit your stage, so right now I have this plain white background, and if you want anything else, you can click on the stage icon on the bottom left corner and then go to backdrop tab. You can choose a backdrop from the library. And again, they have a pretty good collection of very random backgrounds. One of which is a math background right here, which for this particular project may not be applicable, but depending on what you're doing, this is actually a really useful background. And you could also be using this background while you're programming just as a guide, and then just remove it later. So for now, though, I don't want my cat playing paper, rock, scissors in
Forever.
in math land. So I'm going to change it to the desert, and we can do something like that. Okay. So once you are done with your project, you can share it and make it public. So first step is to just rename it. You probably don't want to share a project that says untitled. And then you click on the share icon, and that brings you to this page, which is your project page, and you can put in instructions. And in this case, there's not much to it because it's just an animation. But if you have a game, then it's very important to put real instructions to people. Like, you have to press the space bar for something to happen. And if you have any notes and credits that you want to mention, if you use the photo that you found online or something, make sure it's okay to use it, but you need to still give it credit as well. You can also add tags. So if you made a project that has to do with science, you can put science there or things like that. You can have other people comment on it, or you can turn off commenting if you don't want anybody to be commenting on it. And so once you share, when somebody reaches your project, this is the page they will see. And then you can click on the see inside to actually see the program. What you'll find in Scratch is any shared project, you can see the inside. You can see the program, and you can do something called remixing. So let me go back into. I'm going to go back into Scratch and show you what I mean. So this is my Scratch homepage. Let me just click on one of the featured projects. Let's see. Just want to make sure it doesn't have any inappropriate content.
We have a question.
Yep.
Can you turn off commenting afterwards?
Yes.
That is, if someone has commented, can you delete comments?
I'm actually not sure if you can delete comments, but you can definitely turn it off later.
So everything will be not visible.
I believe so.
Right. Okay.
Where was I? So, all right, let me just. All right, let me try this make a flag one. I've never seen this project. It was just featured on the homepage, so I don't know what it's about. But you can, so this was a shared project made by someone else, but you can still see the project, see the inside, and you can do something called remix. And when you remix, it saves a copy of the project into your own folder, and then you can modify it, which is an interesting way of learning how to program. Scratch really encourages doing that. However, when you're using it in a classroom, you kind of have to be careful because sometimes, we've seen very impressive projects that with no credit given to the original program. So you just got to be aware of that. When you say remix, so now it copied put a copy on my stuff. This is my account. It made a copy and it remixed, but it does tell me that the original project is this other project. And there's also something called a remix tree, which is kind of cool. It like traces back where your project came from. So if the project, somehow it's not working, but if the project has been remixed by multiple people in different ways, you will see like a little tree, which is kind of interesting as well.
It's also, when Scratch suggests remixing, it's also sort of allowing you to play with different codes. So recognizing that you're giving credit is very important because original codes can come from many different projects. And, it's okay, but make sure that you mention the credits.
And also, as a teacher, you can create a remixable, almost like a template of a project, and then share that with all of your students, and then have the students remix your template. That works as well. So where was I? So I'm gonna actually show you what the homework is before I move on to the more stuff in Scratch. Oh, before that. So I just want to show you some of the strands from the digital literacy and computer science standards. Just because this is for grade 3 and up, I pulled out the standards that were in 3 to 5, but there are also similar standards in middle school and high school age as well. So for 3 to 5, this is under the computational thinking strand of the computational thinking strand, and then under that, the algorithms. So a lot of these, pretty much it hits all of these 5 strands. Different solutions to the same problem, which is exactly what we showed you with the move things. Use logical reasoning to predict outcomes of an algorithm, which kind of comes back to having a plan before you start, rather than just randomly trying things and putting, and calling it okay, which is okay when you're still learning the blocks. But at some point, you really want to have a plan and execute it, and do a lot of problem solving that way. Individually and collaboratively create an algorithm to solve a problem. Again, move a character through a maze, or even just moving a character from one place to another on the screen in some pre-planned manner is solving a problem. And detecting errors, which in this case, so like earlier, I made the dinosaur jump up and down, but initially I couldn't see anything that was happening because I forgot to put in the weights. So as you're programming, you will hit a lot of these logical errors, and you will go through a lot of problem solving. And then another strand within the computational thinking is program and development, and basically all of these things will be covered if you're doing Scratch projects to a certain extent. We already did repetition. We didn't do any conditionals today, but we will get there
for the game
session as well.
Well, you could also make the dinosaur jump unconditionally. Go ahead.
So The assignment will have, there is another quick exit ticket, and then your main piece is doing a project very similar to what I just did. The only requirement is you need to have 2 sprites, or at least 2 sprites that move. So like this example I had, you need to use the green flag block. Some motion blocks, I'm not going to say which one because that would depend on what you want to do. And say, wait, and repeat. And then anything else are optional. You're free to explore more and to see what other things can happen. And then I need you to share the project and then share that link in the forum so that we can all see your project. And I also want you to view other people's project and comment on them. So that's also part of the project. Part of the homework. So there's 3 pieces to it. So the example I just did, basically something like this would satisfy all of the requirements for the homeworks because it had 2 sprites, it had all these blocks, and then everything else is optional. So that's fine. And then I want to share some extra resources. Oh, before that, there are some recommendations. So again, I want you to make sure you have a plan before you do the project. And try to stick to the plan, although things may change if your plan is something that you just can't do in Scratch. Then you're going to have to change it. But part of the exit ticket is for you to write what you plan to do. And we're not going to hold you to it 100%, but we'd like you to try to stick to your plan. And then test small pieces of the code as you go. That's always a good idea when you're coding something. You don't want to create this big, huge code without testing anything. And then test, because the longer the code, the more difficult it is to pinpoint where the problem is. So like when I was programming the paper, rock, scissors, I started out with the cat and I made sure the cat was able to come to the middle. And then I moved on to the dinosaur, did that part, and then I did the jumping up and down. So you want to make sure you're testing each piece of it separately as you go. And that's just a good practice in general for coding. Feel free to explore other blocks. Like we said before, Scratch does not break.
We have a suggestion from Brian. You can delete your sprites by either right-clicking on the sprite or the scissors on the top of the page.
Yes, so
that's a good suggestion,
That's a very
Brian.
good point. I never showed you how to delete something. So there are multiple ways to do anything in Scratch. So one of the ways to delete a sprite is to right-click on the sprite and say delete. And it goes away. The code also goes away, so you need to be careful with that. Let me undelete. There's always undo, which is nice. And then the other thing is you can use this scissors icon at the top and then put it over the sprite you want to delete in your program, and it goes away as well. But just be careful, because when you delete a sprite, all the codes that were attached to the sprite goes away. So let's say that I changed my mind and I don't want to use the cat anymore. I want to use a different sprite. You can either go into the cat and change the costume and make the appearance change, or you can say I want a new sprite. Let's say I want to use a bat now. So let's say, where did that go? So let's say I want to use the bat. But if I just do this and delete the cat, then the code which was working disappears, and I'm going to have to redo the code. So what you need to do in that case is copy your code first by, again, dragging it over to the bat. So now the bat has the same code, and then I can delete the cat. Then I don't have to worry about reprogramming everything. So just be careful with delete. Just, if you're going to use the code again, make sure you copy the code into something before you delete the sprite. All right, so back to here. Where was I? I think I was on the third bullet point. Scratch will not break. It is online. It really doesn't break. We've tried many different things and it doesn't really. The worst that could happen is you put it in the infinite loop and it just keeps on playing, in which case you can just stop it. And to stop a code in mid code, you just press this red stop button. It's very simple, and it will stop. Or if it really comes down to it, you can close the browser too, and it auto saves, so you won't lose anything that you've worked on until then. So again, it's not going to break. So please feel free to explore. and ask for help if you get stuck. Even if it's outside of the things we covered today, if you're doing some of the more advanced commands, feel free to ask us for help, and we will try to help. And additional resources. So there are some curriculums available in Scratch. The first one is CS First, which is it's actually put out by Google. It's an interesting curriculum that was designed for after-school space, and there are different multi-week units with different themes like art or something. Maybe I should just go into it. I should have had that open. What's the URL?
csfirst.com. CS-first.
Okay. And it's really designed for after school, but you could definitely use it in your class as well. And you can actually create student accounts in here, and it kind of keeps track of where they are. But there are different modules, so with storytelling, high C's activity, fashion and design, and there are a bunch of I'm just going to click on art, and there's introduction, animation. So it's really a nicely put together curriculum. The only thing is it is developed for after school space, so it's not very tied into any subject area per se. But you can tailor this to fit into some subject area if you like to. So like if you're doing animation, for example, you can have the animation project be about something that you covered in your class. And that way you can integrate it with other courses. The other curriculum is Scratch Ed. Oh my God, there's a typo there. So Scratch Ed, again, is inside the help menu. And there is a official curriculum in there if I could find it. It's under resources.
Yes.
Of course, I can't find it now. So there are a lot of curriculum that a lot of people have put up. These are put up by various users, but there is one that's officially put out by MIT, the people who
invented
this, but I cannot find it.
MIT Media.
But I will find it and make sure the link is available in BPS Learned. And that one is, again, it's a pretty well-written curriculum, but that one's, again, it's not very integrated with other subject areas. And it's more for like a computer class. And then in terms of more resources, there is Scratch Help, and the wiki is very useful in the discussion forum as well. We did a Scratch webinar series in the spring. It was specifically for integrating in different subject areas. And the webinar series is, was it four-part series?
4-part.
And the playlist is linked to the BPS Learns page. Actually, maybe I'll just go there. So that's the Integrating Scratch webinar series. So you can feel free to watch that as well. I think that some of the things we did today are actually covered in session 2. So we started really slow in that in that series. But as you move on to the third and the fourth part of the seminar series, we did a lot more for advanced commands. So definitely check that out if you're more interested in doing more with Scratch. And we have another Scratch session coming up in session 11, and we will be covering more advanced topics there as well. Like and we'll definitely focus on making games, which then get into things like conditionals and variables, which we didn't touch today, but we will be touching in that session.
Do join in. It's a really great gaming experience. So definitely join in for that. Thank you.
And we have a few minutes left, so I just want to show you a few more projects. So a studio is a collection of projects that you can kind of curate on your own to help you organize your things. And you can insert other people's projects into your studio as well. So you can have like all of your students work in one studio so you can see it in one place, for example. So when we did the webinar series in the spring, we put together this studio. And because that one was specifically about integration, we have a lot of examples in here about how to integrate Scratch with different subject areas. And there's a lot of cool little activities in here. So some are more advanced than what we covered today. But let's see, this was one of the simpler ones, right? So this was a nice little project. It's just a slideshow, and what this is this one was made by someone else. I did not make this. We just found it online and thought it was really nice. And it's a very simple program. It just cycles through a bunch of different backdrops. So you can see that the stage is changing and the backdrop is changing, but it's a lot of different flowers. So if you have a science class and you just, you happen to have a garden in your school and you took a bunch of pictures, you can put together a slideshow, and you can even have students narrating it or have text, have like a sprite with a speech bubble or something explaining what they're seeing to add to that. That's an example of something you could do. This one was a really nice one. This is, again, something I found. This is a very nice little project about the water cycle. And each of these items that you see is a sprite. And as I click on them, another sprite pops up and it explains what each piece is. So this is like an interactive infographic that you could start making with Scratch. And again, we didn't cover a lot of these coding things, but we will cover more of it. And we did cover this in the webinar series too. So if you're interested in doing something like this, you can definitely see it in the webinar series. Let's see one more. Which one was a good one?
Trajectory examples. Oh, but this might be elementary.
Yeah, let's see.
You want to do that? That's a good one.
Which one?
Polygon. Or colonialism.
Polygon is a math example. So it asks for a number, and let's say I put in 6, and then the cat will draw the figure for you. And if you're doing this, you need to get into, okay, how do the number of sides relate to the angles in a polygon, and how do you actually make that happen on a computer screen? So this definitely integrates math and computer science at the same time. And then we also added like extra features. So like, so you could have just had the cat, or just have the image pop up, but now we kind of made it unnecessarily complicated by making the cat actually run around. And there's an additional thing where you can hit the space bar to continue rather than just ending the program right there. So there's a lot of different factors. So it's also a good way to differentiate instructions. If a student is, maybe the objective is to just draw polygons, but then if the student is really inclined to doing this, they can add more features and make the program more interactive and more interesting to look at.
Mm-hmm. It also goes to the vocabulary aspects of it. Mm-hmm. So that emphasizes, doing a Scratch project like this also gets integrated into the vocabulary objectives for the lesson.
Yes, and there are actually also some nice ones, interactive animated stories as well, mm-hmm. which definitely relates to English ELA.
Right.
So this, I believe, is just an animated story. Oh, there it goes. So I think there was sound to this, but I don't think it's playing the sound right now. But it is, it's an animated story, and if you can have students write their own story, or it could be a pre-existing story that they make the animation to. And either way, there's a lot of relationship to ELA and art as well. So I think we're almost out of time. So I'm going to switch back to my presentation. We just have a couple more slides. Again, Learn, Teach, Lead Conference. Again, it's on Wednesday, August 10th. If you haven't signed up yet, please do.
Mm-hmm. We have lots of teachers presenting at this conference. Definitely join in. You'll learn a lot about maybe Google applications or computing.
Yep. Were there any other questions?
No.
Before we stop?
Doesn't look like it. That's it.
Okay. Yep. So this will bring us to the end. And again, the homework is the exit ticket and the project with 2 sprites and the green flag motion block, say, wait, and repeat. And then to post the link in the forum. And actually, let me just show you what a link looks like. So if you have a project link, it should look like this. So it's going to be scratch.mit.edu/projects/ a bunch of different numbers. And if it doesn't look like that, then there's something is not right. So make sure when you share and paste the link into the forum, it takes this form. It has that form. So, and finally, the next session is on Thursday, and we will be going over ABCS principles and ABCSA. So these are the two different AP courses options for computer science.
This is a required course for high school attendees, so it's going to give you an overview of both of these courses. That's on Thursday, July 14, 3 to 4. Thank you.
All right. Okay. Thanks a lot for watching, and we'll see you on the forums.
We will see you on the forum.
Bye-bye.
Bye-bye.